So the today's topic is, you can say, is about given a language, that means given a language, whether it is regular or not, whether it is, you can say, regular or not. So the thing is that is the topic. And of course what we know, what we already been discussed, that if, you can say, if the language is finite, then no doubt you can say, if the language is finite, then we know that definitely it is definitely regular. It is definitely regular if it is a finite. That means you just deduce, if this is language is finite, then it's definitely regular. But the thing is that if the, you can say, language is infinite, if the language is infinite, what we can say, how can we check, how can we check that whether it is regular or not, regular or not. But because, you know, if the language is infinite, then there is a challenging task. Like that, if we say, let we say take an, say, infinite language. So if we take infinite language like L is equals to, say, AB, say AB, AB, like that, AB, 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 and it's going on like that. So you know that to accept this infinite language by the finite automata, the finite automata must have some loop with some pattern. If there is some loop with some pattern, then you can only, you can say, identify, that means that particular language will be accepted by the finite automata. That means what I am saying, that to accept, if we want to accept this infinite, if we want to accept this infinite language by finite automata, you know, the finite automata, the finite automaton that must have some loop, must have some loop with some, you can say, pattern, with some pattern. And this is, you can say, actually tell in pumping lemma, actually tell in pumping lemma, that is actually tell in pumping lemma. That means, and of course that actually there is a principle, that is pigeonhole principle. That means the, you can say, principle behind this pumping lemma, behind this pumping lemma, you can say, there is a well known, if you don't know, then in discrete mathematics I think so, that this particular you can say, this particular uh, principles is there, that is called pigeon hole principle, you can say prison hole principle or prison holes theory. So the pumping lemma actually, you can say, that is a prison hole principle. And if you don't know about the prison hole principle, what we know, say, the prison hole principle is like that. Say if, you can say, there are n people, say there are, you can say, n people who can shake hands, shake hands with one another, and of course the value of n is greater than equals to 1, the prison hole, this, you can say, this prison hole principle that actually shows that there is always a pair of people who will shake hands with the same number of people, same number of people. That means the thing is that, or other words you can say, that means if you can say this is a counting principle, say there are uh, what it comes from, that is just very simple. That means if you can say that is the uh, corresponding holes, the pigeons are there, there are 9 holes, there are 9 pigeons are here. If there are 10 pigeons, then what we can say, at least one hole has more than one pigeon, at least one hole. If the value of n, that means if the number of pigeons is more than the number of holes, what we can say, that at least there should be one hole that has more than one pigeon. At least there are one hole, you can say, has more than one, you can say, pigeon. So that is the main principle. That means the same way the, you can say, that particular that pumping lemma will tell that if there are, you can say, if there are infinite language, so there should be a loop, otherwise this particular language cannot be accepted by finite automata. That particular language cannot be accepted by, you can say, this automata. That is, you can say, tell about the pumping lemma. And the thing is that this pumping lemma fails, you can say this particular pumping lemma fails. That means we are not finding some pattern. If the pumping lemma fails, that means if you can say this pumping lemma, if it fails, then what does it mean? That, you can say, means we are not finding, you can say, some pattern. That is, you can say, the language is not regular. But if pumping lemma does not fail, but if pumping lemma does not fail, it of course does not guarantee that language is regular. You just think of that, মানে এটা কিন্তু মাথায় ভালো করে ঢুকিয়ে নাও, যদি পাম্পিং লিমা ফেল করে, মানে পাম্পিং লিমা ফেল করেছে, তাহলে আমরা প্যাটার্ন পাইনি, মানে ল্যাঙ্গুয়েজটা রেগুলার হবেই না, এটা শিওর। বাট যদি পাম্পিং লিমা ফেল না করে, তাহলে কিন্তু এটা গ্যারেন্টি দিয়ে বলতে পারি না যে ল্যাঙ্গুয়েজটা রেগুলারই হবে। তাহলে কিন্তু আমি গ্যারেন্টি দিয়ে বলতে পারি না যে ল্যাঙ্গুয়েজটা রেগুলারই হবে, এটা কিন্তু মাথায় রেখে। তার মানে পাম্পিং লিমা ইজ এ নেগেটিভিটি টেস্ট, ইউ ক্যান সে pumping lemma actually is a negativity, you can say, test. And what we can say, so we are, you can say, not using pumping lemma, we actually use our intuition to see whether a language is, you can say, regular or not. That means the simple thing is that if we can build finite automaton for a language, then it is surely regular. So that means you should remember one thing, that by using pumping lemma, what does it mean? By using pumping lemma, that is a negativity test. That means if the pumping lemma fails, it is well and good, no problem. But if the pumping lemma does not fail, that will not give you guarantee that this language is regular. That means there are some non-regular language for which the pumping lemma ওই ল্যাঙ্গুয়েজ গুলোকে অ্যাকসেপ্ট করে নিতে পারে, এবং পাম্পিং লিমা যদি ফেল করে তাহলে ঠিক আছে, পাম্পিং লিমা যদি ফেল না করে তাহলে কিন্তু গ্যারান্টি দিয়ে বলা যায় না যে ওটা রেগুলার। ওকে, জাস্ট এ মিনিট, জাস্ট এ মিনিট। So now the thing is that in gate, actually what we can see, that there is no part of pumping lemma. That means the questions that come, the pumping lemma follows what it should be the behind principles follows by pumping lemma, that is a pigeon horn principle that is followed by pumping lemma. And the thing is that but you should express your you should use your intuitions to solve it. But the thing is that in your WBUT syllabus there is a part where you can say you have to use pumping lemma. That means by using this particular pumping lemma you have to show something. That means they will give you that, so that the set is not regular by using pumping lemma. That means at least in that case you should know the pumping lemma, that what the pumping lemma actually say, and then we will move to, because pumping lemma, that is pumping lemma for regular language, and you know about the context free language, just heard the name. In case of context free language there is also pumping lemma. Now the thing is that what should be the pumping lemma actually tells, if we say, because that is important in you can say in WBUT, that you should prove that. That means the pumping lemma, a language is given and they will ask you that you have to apply the pumping lemma and you have to show something, that whether this is, you can say, accepted or not. Now the thing is that if we say pumping lemma, that you can say the pumping lemma, pumping, you can say lemma for regular language. And if we discuss the pumping lemma for regular language, so we can say that let L be a regular language. So we can say there then there you can say exist a constant n, actually which you can say depends on L, such that, say such that for every string W in L, such that the length of the string, this is the length of the string, that is greater than n, we can break W into three parts. We can, this is comma, we can break W into, you can say, three strings. We can break W into three strings. W is equals to, say, x, y, z, such that, how we have to break? The first rule is this y is not equals to epsilon. Second is the length of xy. The length of xy should be less than equals to n. And for all k that is greater than equals to 0, the string, that means that is nothing but the loop constant y to the power k z is also in L. That means if we pump y, if we pump y k times, then also you can say that will also belongs to the same language. That is actually you can say the statement of the, you can say, the pumping lemma. Now the thing is that is of course that is one of the statement of pumping lemma, and that is we can always find a non-empty string y, because y is not equals to epsilon not too far from the beginning of w, that can be pumped. That means we are repeating y any number of times or deleting it keeps the resulting string in the language. That is, you can say, about the pumping lemma. That means the main thing is the y should not be equals to epsilon, and we are, you can say, repeating the value of y. And if we are repeating the value of y, if still that is in the same language, then we can say that should be x y to the power k and z, that should be in L. So that means actually what we want to say, that is we can, you can say, always, we can always find a non-empty, we can always find a non-empty string y that is not too far from the, you can say, beginning, from the beginning of w, that can be pumped, that can be pumped, that is we are repeating y any number of times, or you can say deleting it in case if k is 0, keeping the resulting string. That means after doing this, if the resulting string is still in the language, then we can say that is accepted, that resulting string in the, you can say, language. That means what we are trying to say, that means if a string w is equals to xyz, and that means say x equals to a1, we are breaking the string like that, and say y equals to this is ai, y equals to ai plus 1, ai plus 2 dot 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 aj, and say z is equals to aj plus 1, aj plus 2 dot 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 am. We are breaking the string like that. So what does it mean? That means we can break like that. So if we start from this particular point, we are giving string from a1 to ai, and say we are reaching a string, a state which is pi. Now if we are pump y, that means if we are pump y, what does it mean? That I plus 1 to aj, and after getting, after k number of times, if we are giving this particular strings and we can reach the final state, then we can say that particular string is accepted and that satisfy the pumping lemma. Then we can only say that satisfy the pumping lemma condition. So now let's say one thing. Let's say we are taking a language, say a to the power n, b to the power 2n, that n is greater than 0. So in WBT you have to prove it. That means, say we can that means what is the string? That means a this is a n times, and then you can say this b should be 2n times. That is the string. So now we are breaking like that. This is, we can take this length is xy, and you can say we can take this length as z. We can take like that because the whole string can be the first rule. The first thing is that that y should not be epsilon naught, and xy, the length of xy should be less than n. So in that particular case xy and the xy length xy is should be less than equals to n. That is correct, and we can break like that. Okay, so what we can say, and of course you have to write like that, that xy in that particular case that contains only a, such that you can say the length of xy that is less than equals to n, and say we say the length of y is equals to L, because we don't know what should be the length of y, but that should not be epsilon naught, and of course this where length is greater than 0, because length of y is greater than 0. So we can say break up this x y z as follows. আমি এভাবে ব্রেক করতে পারি, that w is equals to a n minus 1 নিয়েছি, and a b to the power 2n, আমি এইটাকে নিয়েছি x, a হচ্ছে y, আর that is equals to z. So now what we have to do, that means, so w, if we pump it, that means y to the power z, y to the power k and z, and where the value of k from 0 1 to up to, you can say, should be length L. So if we pump that, that means if we say a, this is n minus 1, y to the power k, we can say y, the value of y is taken as a, so a to the power k, and this is z, z means b to the power n. Now you can say, for if we put k equals to 0, what we can find, you just see, if we put k equals to 0, a to the power n minus 1, and that is b to the power 2n, but that is not belongs to language. That means the fact of, you can say, this particular thing will not satisfy the pumping lemma, because pumping lemma says if we pump, that means x y to the power k z, if we pump y times, then if this w is also belongs to the same language, then this w is accepted. But in that particular case, what we see, if we pump the yk times, and we can take k any, but you have to follow the rule that y cannot be epsilon, and the length of xy should be, you can say, less than equals to n. And if we satisfy this, you will find, if we put the value k, then this terms is a to the power n minus 1 and b to the power 2n. But what is the language? Language is nothing but that is given, that is a to the power n, b to the power 2n. That means that particular w after pumping y, that is not belongs to this. So you can say it is not, you can say it is not regular. It is not regular. So you can say like that. That means in maximum time, they in the, every time they will say that, show that this particular language is not regular, like that. So I think that at least you just get an idea that how we can prove this. I am just getting it, just you just feel that how can we prove this. That is the one of the main thing that you should understand.
আচ্ছা বলছি পাম্পিং লিমাতে মানে ওইটাকে পুরো স্ট্রিংটাকে ভাঙতে হবে, মানে এই
একদম
n-1 করে,
একদম n-1 করে ভাঙতে হবে।
মানে এটা কি পরীক্ষা যে সেমিস্টারে আসলে মানে এটা এরকম করে না করলে মানে মার্কস কেটে দেবো?
একদম, এটা এরকম ভাবেই করতে হবে। আমি তোমায় আরেকটা এক্সাম্পল দিই, বাকিগুলো হোমওয়ার্ক। আরেকটা এক্সাম্পল আমি লিখে তোমায় দেখিয়ে দিচ্ছি, হোয়াট ইউ শুড রাইট ইন দ্য এক্সামিনেশন। মানে অন্তত প্রুফটা, ওই 3টে রুল যেন লিখে আসো, তাতেই অনেকটা নাম্বার পেয়ে যাবে, বুঝতে পেরেছো? তাতেই তোমার 70% নাম্বার তোমরা পেয়ে যাওয়ার কথা। সে মানে ধর,
মানে স্যার ওই 3টে কন্ডিশন যে দিলেন,
একদম 1 2 3, আমি তোমায় একটা লিখে দেখিয়ে দিচ্ছি যে এইভাবে পরীক্ষায় লিখলে যেমন ধরো তোমায় বলে দিল যে এরকম কোশ্চেন দেবে, শো দ্যাট L is equals to 0 to the power I, say 1 to the power I, and I is greater than equals to 1 is not regular, by using pumping lemma. So the thing is that what we have to write, so it should be আমি আমরা লিখে দেখিয়ে দিচ্ছি যে like that we suppose L is regular, and we prove it, we you can say we will prove it through, you can say, contradiction, through, you can say it would be better proved by contradiction. Okay, so let say n, you can say, be the number of states in the finite automaton that accepting L. So the first is case 1, where we know that, so we can say let this W 0 to the power n, 1 to the power n, we can write like that because we are taking that n is the number of states, and then the length of the W, that is equals to 2n, of course that is greater than equals to n. So by pumping lemma we can write this W is equals to xyz, with the condition is xy length, the length of xy should be less than equals to n, and length of y it should be greater than 0, that is length of y, you can say that should be, you can say, you can put 0, that you can say otherwise okay, length of s 0, that means it is not equals to epsilon, that is right. So now this is the case 1. So in case 2 we have to break it, so we want to, you can say, find I, so that what we have to show, that if we pump I times or k times whatever be the, that should not belongs to the language. Okay, that you have to prove, that means we have to find I, so that if we pump y I times, that should not belongs to language. And for getting it, we can say that that particular string, that you can say, can be of any following from, that means what we can say, the language is 0 to the power n, and you can say 1 to the power n, 0 to the power n, 1 to the power n. So we can say that the string y, the string y can be any of the following forms, any of the following forms. What does it mean? That means because that is a combinations of, you can say, 0 0 and 1 1 combinations, and the length of the 0 should be n and length of the 1 should also be n. So you can take that y has zeros, I don't know, that means we can say that should be the portion of xy, and that is the portion of z. That means the first options, you can say y has zeros, that is y can be written as 0 to the power k, for, you can say, sum k is greater than equals to 1, you can write like that. Otherwise you can break like that, that means 0, you can say y has only 1, but that cannot be possible, but y has both zeros and 1, so you can say if we take like that, that means y has zeros and as well as this k. Now if we use pumping lemma, that means x, y to the power k and z. So what we find from the previous diagram, what we can find, that this particular can be broken like that. We can say it should be 0 to the power n minus 1, y is only 0, and you can say that is 1 to the power n. We can write like that. That means this is x, this is y, and this is z. So now if y to the power k z, and of course what does it mean? That means you can say 0 to the power n minus 1, and this is 0 to the power k and 1 to the power n, and the value of k is 0, 1 up to that. So if we put k is equals to 0, so what we get, 0 to the power n minus 1, this w, and this is 1 to the power n, but it not belongs to the language, because the language that is given 0 to the power n, 1 to the power n. So you can say that is not regular. So what we can say, that L is not regular. So by which you can prove that, there may be several way to prove, but that is the one of the easiest thing that will come in your exam. Just you are pumping this thing. So the thing is that I am giving some home task that you will at least try in home to prove it. Not like that you have to prove it, because that may come in your WBUT, that so that the set, say L is equals to a to the power I square, that means I is greater than equals to 1, is not regular. This is, or you can say that the same thing, that so that L is equals to a to the power p, that means p is prime, is not regular. So you just prove these two things, that would be, I think, more than that. So that is the thing, that means that is the part of pumping lemma, and that is for only regular language. But we will try to identify the language, and just to see, and we have to think something, and then we can say that whether this is regular or not. So just look at that. That is one of the important thing. Say it is given a to the power n is greater than equals to 1. So what we know, that we can design the finite automata, that is by intuition we can design the finite automata for that. That means of course that is called regular language. Now say a to the power n, b to the power m, and n and m is greater than equals to 1, and for that we can also design that. That means after getting a, that is goes, and a to the power n and m has no relations between them. That means a will be occurring like that, and b, and that is the final. And of course we can design a finite automata for that particular language. That means you can say that is a regular language. Now the thing is, a to the power n, b to the power n, and say n is less than equals to 10 to the power 10 to the power 10 to the power 10 to the power 10 to the power, like that, whatever 10 to the power. But in that particular case, you just remember the thing, since this particular n is bounded, whatever be the value, but still it is bounded. So this particular language, it may be, it will take 1 lakh steps, or it may be, you can say it will take 1 crore step, but n is bounded. So language is finite. So the language is finite, and of course you know that every finite language is regular. Every finite language is regular. What we can say. Now, if the question is like
স্যার
that,
বলছি এইগুলো কি ম্যাকআউটে মানে প্রুফ করতে হবে আর ওই পাম্পিং লিমার দ্বারা প্রুফ করতে হবে না এমনি লিখে দিলেও হবে
না
মানে
পাম্প
এগুলো যদি দেয়
এইগুলো যদি অপশনে মানে অপশনাল কোশ্চেনে দেয়, ঠিক আছে,
হ্যাঁ স্যার
তাহলে তুমি লিখে দিলেই হবে, ঠিক আছে,
আচ্ছা আচ্ছা
বাট দ্যাট ইজ মেনলি কাম ইন গেট। ওকে, গেটে যেমন এগুলো
আচ্ছা
আসে,
ঠিক আছে ঠিক
বাট
আছে
মাকাউটে পাম্পিং লিমা দিয়ে যদি পেশা দিয়ে লিখে দেয় তখন করতে হবে। আর যদি পাম্পিং লিমা না
আচ্ছা
কথাটা ইউজ করে তাহলে তুমি এমনি বলতে
মানে
পারো।
এমনি বলে দিলেও মানে যদি
একদম,
এমনি লিখে দিই তাহলে তাহলে
তাহলেই
মার্কস
হবে,
দেওয়া উচিত
তাহলেই মার্কস দেবে একদম। কিন্তু যদি তোমায় স্পেসিফিক্যালি বলে যে ইউ হ্যাভ টু ডিজাইন ইট থ্রু পাম্পিং লিমা, দেন তোমায় পাম্পিং লিমা দিয়ে প্রুভ করতে হবে। আদারওয়াইজ ইফ ইউ জাস্ট রাইট ইট ইন ইউর ওন ওয়ার্ডস, দ্যাট ইজ কারেক্ট। ওকে, বাট দ্য থিং ইজ দ্যাট, যেটা আমি বলতে চাইছি, এইখানে ল্যাঙ্গুয়েজগুলো দেখে যেন নিজেদের মাথায় একটা স্বাভাবিক ইনটিউশন গ্রো করে এবং সেই ইনটিউশন দিয়ে যেন তুমি বলতে পারো যে অ্যাকচুয়ালি ল্যাঙ্গুয়েজটা রেগুলার কি রেগুলার নয়। দ্যাট ইজ দ্য ইম্পর্টেন্ট থিং দ্যাট ইউ শুড প্র্যাকটিস লাইক দ্যাট। এবং এইগুলো গেটে দেবেই, যেমন লাইক দ্যাট a টু দি বার n b টু দি বার n ইজ গ্রেটার দ্যান ইকুয়ালস টু 1 যদি দেয়, in that particular case you just see n is unbounded because n is greater than 1, but how much, that is not given. That means you can say here n is unbounded, that means there is no boundness, unbounded. So what we have to do first, you have to count a. Of course you have to count a because this a to the power n and b to the power is also n. That means you have to first count a and then you have to count b. But since a and b are not limited, that means they are not bounded, that means finite automata কতগুলো স্টোর করবে, মানে n এর ভ্যালু তো তুমি জানো না, তাহলে তুমি এখন n ভ্যালু যদি অনেক বেশি, তাহলে তোমার কোনো ফাইনাইট যেহেতু ভ্যালু নেই, তাই মানে তুমি এটা ফাইনাইট মেমোরিতে স্টোর করার কোনো জায়গা নেই, এবং তাই জন্য ফাইনাইট অটোমেটা দিয়ে এটা করা যাবে না। সো ফার্স্ট হোয়াট ইউ হ্যাভ টু ডু, ইউ হ্যাভ টু কাউন্ট a and then you have to count b. But you know that finite automata, automata can count finite memory. That means if we have a finite memory, then only you can count. So you can say it is not regular. It is not regular. You just remember. Now semi, if we write WWR and W is equals to 2, this sigma is equals to AB. So tell me if the language is you can say written like that. So whether it is regular or not regular, what do you think?
স্যার রেগুলার হবে মনে হয়
আচ্ছা, রেগুলার কেন হবে?
স্যার কারণ ধরুন আপনি মানে কোনো একটা স্ট্রিং নিচ্ছি মানে ডাব্লিউ ধরুন এ এ মানে এ ঠিক আছে দিয়ে ওর ওর রিভার্সটা করছি তাহলে চারটে মাত্র কম্বিনেশন পাবো মানে এ বি তারপরে আবার বি এ মানে রিভার্স করে মানে তারপরে এ তারপরে ওটাই আবার হয়ে যাচ্ছে এ কিংবা বিবি কিংবা
Okay,
বিবি কারণ
so
এখানে তো ফাইনাইট নেস আছে মানে
okay,
ইনফাইনাইট নেস তো নেই
okay, তার মানে you say that this is either AA or AB or BA, that should be BB. And if we take this is a W word, that means reverse, that means either AA, that should be BA, or AB, and you can say that is a BB. So that means since when this length of W is bounded, when this length of W is bounded, it is regular because that is a finite language. But the thing is that if you say that language L is equals to WWR and W is belongs to, you can say AB star, and that is nothing but that is not regular because W is not bounded. It is nothing but set of all, you can say, palindrome. This is nothing but the set of all palindromes, and you can say which is unbounded, which is unbounded. So you can say it is not regular. Okay, And if we write the language is like that w, and of course w is belongs to a b star, that means what you have to say, you have to check. But since the w has no such limit, that where from we start, because w is a sequence on a and b, that means you just write say w is equals to a b b b a b a like that. So if we check whether the language is same or not, a b b, you can say b a b a, and again a b b a b a. Now how can you find that whether this a is the middle point, or this a is the middle point, or this a is the middle point? You cannot. And of course the length of w is not fixed. So in that particular case, you have to, what you have to do, for you can say for that case, for that particular case, what you have to do, you have to, you can say, save w in memory. You have to first save w in memory, and what you have to do, then you can compare, then you can say you can compare it with, you can say, w. But you can say w may be infinite, but w may be infinite. So you know that it is not possible to store it. So it is, you can say, not possible to, you can say, store it by finite automata. So you can say that is not regular. That is not regular. Now if we say like that, language L is equals to a to the power n, b to the power n, and c to the power k, where n, m, and k that is greater than equals to 1. So whether it is regular or not, what we can say about that?
স্যার রেগুলারই হবে।
Regularly হবে. Why? What is the reason behind that?
স্যার কারণ এন এম আর কে এই তিনটে মানে মানে আপনি এন এম
বাউন্ডেড
যদি
টু দ্য
এখানে
ওয়াইড
শুধু
থাকে।
শুধু এন এন দেওয়া থাকে মানে মানে এখানে এনটা মানে কয়েকটা নাম্বার নিচে দিয়ে তারপরে মানে ওটা খতম হয়ে যাচ্ছে, দিয়ে তারপরে বিটা মানে কয়েকটা নাম্বার নিচে দিয়ে ওইটা ইয়ে হয়ে যাচ্ছে,
That
তারপরে
means
আমি সিতে যাচ্ছি,
স্যার
কারণ
একদম।
এন এম কে এর মধ্যে
এবিসি
কোনো ইয়ে নেই,
এবিসি যে
ডিপেন্ডেন্সি
কোনো
নেই।
নাম্বার অফ টার্মস হতে পারে,
Yes.
তো তাই জন্য উই ডোন্ট হ্যাভ টু কাউন্ট,
Yes, you
তো তাই
don't
জন্য
have
হতে
to
পারে।
count. That means we are not counting A or B or C, because A should be any number. The main thing that you notice, that the relation, there is no relations between the number of A's with number of B's or with number of C's, and that's why that is nothing but, you can draw a finite automata for there, and that is nothing but regular. And the thing is like that, if we write L is equals to, you can say, a to the power I, b to the power 2j, where say I and j is greater than equals to 1, you can say, and that is also regular, because this I and j, that are, you can say, independent, that are independent of, you can say, each other, that are independent of each other. And of course we need not count it, need not, you can say, count it. So that is also, you can say, regular, that is also regular. Now the thing is that, so that means if the language is, you can say, a to the power I, b to the power 4, say, that is also, you can say, regular, because I and j are independent. So you can say that is a regular. But if we can write like that, a to the power n, b to the power n, c to the power n, n is greater than equals to 1, then you have to count the number of A's with the number of B's, and as well as with the number of C's. That means that is, you can say, not regular, because n, m, because you have to first store A, then how many A will be stored, then that should be checked with the number of B's, and that will again checked with the number of C's. But the thing is, there is no place, because A and B, that is no limitations has been given, so you cannot store like that. So now let we are taking the sigma is nothing but a single alphabet, that means A. Now if we write that L is equals to a to the power n, n is even. That means either you can say a to the power 0, a square, e to the power a4, like that. So of course that particular string length is in AP, right? This string length you can say is in AP series. That means you have to take the common difference, and you can this particular common difference you can you can put it into loop. That means you can say you just take the common difference, you take the you can say common difference, and in the loop, common difference in the loop. So you can build the finite automatas, and you can say that is nothing but regular. And now if you can say L is equals to an and n is odd, that is also regular, you can say, because that is a to the power 1, a cube, a to the power 5, and also they have some common difference. That means string length in you can say AP, you can say that is also regular. Now if you can say L is equals to a to the power n and n is you can say prime, but the thing is that particular prime number, this prime number you cannot put it you can say cannot in AP. So that is one of the procedure to check if this is given, that whether the thing that is given whether it is in AP or not. Since it is not AP, so you can say so not you can say regular. And you can say like that if the language is given, say you can say a to the power n square and n is greater than equals to 1. So if we say that is say a to the power 4, a to the power 9, a to the power 16, a to the power 25, like that, and of course that is not in AP, so you can say not you can say regular, because you cannot find any common difference. If you can find the common difference, you can put it in a loop. You cannot find it, so it is not in AP, so not regular. Or if it is given the language is say a 2 to the power n, that is exponential, n is greater than equals to 1, then you can say what should be the language, either a square, a4, a8, a16, and it goes on like that exponentially, and of course not in AP, so you can say not regular. So you should remember the thing. So if we just change the alphabet set, say A and B, and say the language is given, that is you can say a to the power I, b to the power j square, and I and j that is equals to 1. So Srijita, can you tell me that whether this is in regular or not? Do you think that that is a regular or that is not regular?
Sir, this is not regular.
Why this is not regular?
So এটা তো I, তো সেটা ঠিক আছে, বাট যেটা j স্কয়ার, তো কমন ডিফারেন্স তো হবে না এপি তে নেই বলে।
Okay, the thing is that in that particular case, you there is no I and j are not dependent on each other, but b to the power j square that is not in AP, so that is not regular. That means in the next time you should check if there is not dependent on I and j. That is not the only conditions to check that they are not they are regular. You have to check whether these are in AP or not. So you just say that is not you can say dependent on I and j, but in that particular b j square is not in you can say AP, so you can say so not regular, so not regular. And similarly as that, if the language is given like that a to the power I, say b to the power 2 to the power n, and say I and n is greater than equals to 1, in that particular case also, this b to the power 2 to the power n is not, you can say, in AP. So you will not find any pattern. So that is not, you can say, not regular. And also if we write language is equals to a to the power I, b to the power p, where say if p is greater than 1 and p is prime, so we know that b to the power p, you can say b to the power p, if p is prime, it is not in, you can say, AP, so you can say not regular. So you will understand that stuff particularly. Now another thing that is you should remember, that means there are some examples, you can say, where the, you can say, counting that matters. Counting matters. That means say this sigma is equals to a b and this w, you can say, that is belongs to a b star. That is the length of the string, that is the combinations of a b. And say the language is given like that, number of a's should be equals to number of b's in that particular case. And in that particular case, since w has infinite length, because you know w is a b star, so it has infinite length, it has infinite length, so you can say not regular. So it is, you can say, not regular. Or if it is given that the language is w where number of a's less than equals to number of b's, or you can say line w where you can say number of a's that is greater than equals to number of b's, that are all, you can say, not regular, because w has, you can say, infinite length. W has infinite length. But if it is given that this language is w na, say, mod 3, that is less than equal, that we already been solved in finite automata problem, say, then it is regular. Then it is regular, because we are giving some restrictions to the length of the w. That is all, you can say, regular. So now I am giving some, you can say, some problem, and just tell me, sometime you will take some time and tell me that whether this is regular or not. Say, take some time. After completing all those stuffs, I will ask you, then you just give me the answer, that you can say a b star, say language is e to the power n, b to the power n plus m, c to the power m, n and m is greater than or equal to 1. This third part, say language equals to w x w r, w and x, that is belongs to plus. So just tell me these three things, that whether they are regular or not. yes, বলো।
স্যার প্রথমটা ইররেগুলারই হবে।
প্রথমটা রেগুলার।
না না মানে নট রেগুলার।
Okay, that is not regular. Okay, this one
সেকেন্ডটাও নট রেগুলার।
not regular, and the third one
স্যার রেগুলার হবে।
it's regular.
হ্যাঁ স্যার।
Okay, why?
স্যার কারণ ধরুন ওরা ডাব্লু কোনো একটা স্ট্রিং নিয়েছেন আর ডাব্লু আর মানে ওইটা তো রিভার্স, তাহলে এক্সটা আমি মানে যা খুশি নিই না কেন, মানে 0 1 যা খুশি নিই না কেন, মানে ওইটা কি করবে, মানে ওইটা মানে এই দুটো স্ট্রিংকে মানে পুরোটাকে কভার করবে, তাহলে শুধু ফার্স্টের যে ডিজিট আর লাস্টের ডিজিটটাই বাকি থাকবে, মানে তাছাড়া আমি যে কোনো ডিজিট মানে নিতে পারি। মানে যদি আমি রেগুলার এক্সপ্রেশন করি এর, তাহলে ওইটা আসছে মানে যদি আমি 1 নিই ধরুন, মানে মানে পুরোটাই এক্সপ্যান্ড করে যাবে, মানে খেয়ে ফেলবে ওটা।
আচ্ছা, যেটা ও বলতে চাচ্ছে সেটা আমি তোমায় বলে দিচ্ছি। ইন দ্যাট ফার্স্ট কেস দ্যাট ইজ নট রেগুলার বিকজ w you know that be anything, but you can say but not finite. Of course that is not finite, so that is not regular. And of course here you just see you have to first count number of a's and then number of c's, and the number of a's and
বিটা ডিপেন্ড করে এ আর সি এর উপর।
okay, the value of that will depend on the value of a and c, and that is not possible because
we
we
can count.
yes, we have to, if we want to count then you have to store infinite string, and that is not possible, and that is not possible for finite automata. So that is not regular. But the third thing that is interesting, what actually he wants to, if say w is equals to 101, say x is equals to, you can say 100, and say wr, that is the reverse of w, that is 101. So you can say the string wx wr, that you can write 101 100 101, that you can say, that means this is w, this is you can say x, and this is wr. Now you can say here it is given that w and x can be anything, the combination of zeros and 1. So what we can sign, since what we can, you can say extend x. So what we can say, this 101 100 101, that all be taken within x. That may be because x can extend such that, and that is w and that is wr. That means the middle part except the last bit can be taken at x, because x has no limitations, because there is no bound to take x. So it is nothing but starting and ending with the same string. That is also one of the important things that may ask in GATE or in some competitive exam. By seeing this, you can say that is nothing but the starting and ending with the same string. That is same as that. That means what I am saying. So in that particular case, the middle part, you can say except the, you can say the last bit, except the last bit can be, you can say, taken as x. So, and since we have no bound, and of course we can say since we have no bound, we have no bound to take x, so it is, you can say, nothing but, you can say, starting and ending, you can say, with same string, ending with same string. That means if we can write the regular expression, you will find that means 1, that is a any combinations of zeros and ones, 1, or it can be start with 0, any combinations of zeros and 1, and end with 0. So of course it is, so it is, you can say, regular, you can say. but the thing, if we do some modifications, if we do some say modification of this particular string, that means if we give some bound on x, that means say w language is wx wr, and w can be 0 ones, but the length of x say that is given 5. So since you are bounding the value of x, that means that cannot be non-irregular, because x has some restrictions. So you cannot take the whole strings, just the last bit গুলো ছাড়া বাকি সব string কে x হিসেবে কাউন্ট করতে পারবে না, কিন্তু বিকজ x এর একটা বাউন্ড দিয়ে দিয়েছে। সো ইন দ্যাট পার্টিকুলার কেস এটা কিন্তু নট বি রেগুলার, এটা হচ্ছে ইউ ক্যান সে নন রেগুলার হয়ে গেল, বিকজ ইউ ক্যান সে লেন্থ, you can say x has, you can say some restriction, length x some restrictions, you should remember that. Now you can say, if we say write like that, say the language is written like that, x w w r y, and you can say x y and w, that is belongs to 0 1 plus. In that particular case also, what we can say, if we take x is say 1 0, w is say 1 0 0, then what we know, and say y equals to 1 1, so wr is nothing but 0 0 1. So what we can write the language as 1 0 1 0 0, that means we are writing like that, x is 1 0 and w is 1 0 0 and wr, that is 0 0 1 and y is 1. So that means you know that is x, that is w, that is wr, and that is y. So in that particular case you can say that can be nothing but a set of all strings that will contain 0 0 or 1 1 as a substring, because you can say that will contain 0 0 at least, or if you can say write, we can write either it can be 0 0 or either can be you can say 0, because if we take 0 and wr is equals to also 1 0 1, you will see that that should be anything, that is 1 0 1, this is 1 0 1 1 1, that means you just see that it will contain a substring 1. So it is nothing but, that is also one of the interesting observations, that is set of, you can say all strings, you can say containing 0 0 or 1 1 as a, you can say substring, as a substring. So you can write a regular expressions of course for that, that means any combinations, either 0 0 or any combinations, or you can say any combinations, either 1 1 any combinations. So it is, you can say regular, so it is regular. But if we write like that,
স্যার বাট এটাতে তো মানে মানে এরকম হতে পারে যে সাবস্ট্রিংটা 0 0 বা 1 1 হলো, বাট মাঝেরটা w আর w রেগুলারটা মানে মানে রিভার্স নাও হতে পারে, এরকম তো হতে পারে।
তুমি যা খুশি নাও, তুমি ভেবে দেখো, তুমি যদি রিভার্স করো w আর w r কে, আইদার 0 0 আসবে অথবা আইদার 0 1 1 1 আসবে, তাছাড়া কিছু আসতে পারে না। তুমি করে দেখো, তুমি যে কোনো স্ট্রিং নিয়ে দেখো, তুমি একটা স্ট্রিং বলো, ধরো
হ্যাঁ হ্যাঁ হ্যাঁ, সেটা থাকবে, এরকম অনেক কেসও তো হতে পারে যেটাতে ওটা থাকবে বাট ওটা এই ল্যাঙ্গুয়েজের মধ্যে হবে না।
ওই ল্যাঙ্গুয়েজের মধ্যে, আমি তো ল্যাঙ্গুয়েজটাই হচ্ছে 0 0 সাবস্ট্রিং অথবা 1 1 থাকবে, বাকি তো আমাকে কনসিডার করা দরকার নেই, কারণ এটা তো যে কোনো কম্বিনেশন হতে পারে, দ্যাট শুড বি অলসো অ্যানাদার কম্বিনেশন, যা খুশি কম্বিনেশন হতে পারে, ইউ ক্যান জেনারেট এনিথিং, বাট অ্যাটলিস্ট একটা 0 0 বা অ্যাটলিস্ট একটা 1 1 থাকবে, তাছাড়া তো অন্য কিছু আসছে না। তুমি দেখো হিসেব করে, তুমি তো বাকি তো যে আগেকার কম্বিনেশন, সেটা তো ধরো যেটা এক্স আর ডাব্লুর ওই যে পার্টিকুলার কম্বিনেশন যেটা আমি দাগ করেছি, সেটা তো যে কোনো কিছু হতে পারে, তাই জন্য তো আমি বলছি 0 1 এর যে কোনো কম্বিনেশন আসতে পারে, বাট অ্যাটলিস্ট একটা 0 0 একটা 1 1 থাকবেই তোমার স্ট্রিং এর মধ্যে, তাছাড়া তুমি এটা করতে পারবে না। বাট যদি এটা তুমি উল্টে দেওয়া হয় তাহলে কিন্তু থাকবে না। তুমি দেখো এই পরের এক্সাম্পল, যদি আমি তোমায় বলে দিই একটা ল্যাঙ্গুয়েজ and it is x and w w r, where you can say x and w that is belongs to 0 1 plus, you will say w is equals to 101 and w r equals to also 101 and x say 1 1, then you cannot find any pattern because this is x, if this is w and this is w r. So even if we extend x, we cannot guarantee that at least 2 bits may be 0 0 or 1 1. But in the previous case that will be guaranteed, মানে either it should be 0 0 or either it should be 1 1, এই দুটো ছাড়া আর কিছু কম্বিনেশন থাকবে না, মানে এটা গ্যারান্টি। But in that particular case what we can say that even if we extend x, we cannot, you can say, guaranteed, we cannot guarantee that last 2 bit that may be 0 0 or 1 1. So you can say it is not regular, it is not regular. And also if we write the opposite case, that means if we write say L is equals to W W R Y and W Y that is belongs to 0 1 plus, if we write the language like that and you just see this is 101, this W R is equals to 101 and Y equals to 10, what we can say 101 101 and 10, if this is W and it is WR and it is Y, then we are also not finding any pattern. So it is also not, you can say, regular, it is not also regular. So এই প্যাটার্নের বাইরে আর কিছু আসবে না, এই প্যাটার্নগুলোকে একটু ওয়েল কেয়ারফুলি খুব দেখতে পারলেই তুমি যে কোনো রেগুলার ল্যাঙ্গুয়েজ দিস না কেন তুমি এটা করতে পারবে।